So I'm going to talk about how the dialogue between instructors and students facilitates learning in a laboratory setting. My name's Jacquie Robson. My co-researcher on this project was Dr. Helen Crammon, who's from the School of Education at Durham. I'm from the Department of Chemistry. And Megan Gerard was the fourth-year research student that carried out this research for us as part of her MChem project. So I'm going to cover some background introduction, talk about the aims and the context of this study, the methodology that we used, and show you some of the results and findings. We used 3 different methods of analysis for the data that we collected, and then I'll finish off with some conclusions and things we're going to do next. So learning in a teaching lab is not only achieved through the completion of an experiment, but is constructed in the conversations that occur. And I think we'll all agree that, you know, conversations between teachers and students are essential, but also students and students. And thinking about how they construct their knowledge is really important if we're going to make sure they understand what it is they're doing in the laboratory. So we used Novak's background framework as the theoretical underpinning for the start of this project. Novak wrote The Theory of Education in 1977 and states very sensibly that meaningful learning is the purposeful connection between new information with a student's existing knowledge. So this idea of building knowledge and growing knowledge. And considers 3 domains, so cognitive, affective and psychomotor, so thinking, feeling and acting, and the integration of these. And Megan particularly liked this framework for the theoretical underpinning of her project because that's what she felt went on inside a laboratory, and I quite agree with her. So students should be thinking, feeling and acting to successfully complete an experiment. So conversation interactions in a laboratory allow sharing and negotiation of meaning. So we think of that as sense making to promote meaningful learning, to get them to understand what they're doing. So that was the background we started from. Our aims were to analyse how dialogue between students and between student and demonstrator might facilitate student learning or not. In fact, originally we were just looking at the student-demonstrator interaction, but we captured student-student interactions as well. So we did this study in the first-year chemistry undergraduate lab at the start of term 2. So students had had a term in the lab already, so they knew each other. We had 2 sessions where we recorded 2 students in each session, so 4 undergraduate students in total. So this was a small-scale study. We labelled the students A, B, C and E because D was the demonstrator. They worked individually at benches but were next to each other so they could talk to each other. There was one demonstrator who oversaw all 20 students doing that experiment. This was a live lab session. This wasn't set up just for this study. So the demonstrator would come over occasionally and talk to the students and left the students to get on with it for the rest of the time. The experiment that they carried out was titration analysis of a vitamin C tablet. So they're standing next to each other, both doing the same experiment. And we kitted them up with a lapel mic each. And we gave them a pen mic to write with. So we have some Echo LiveScribe pens, which are fab, and they record what the student writes and what the student says. The demonstrator wasn't mic'd, they just came over and spoke to the students, and the lapel mics picked that conversation up. We also asked students to fill a questionnaire in to get background information because we were interested in looking at maybe whether confidence and things like that would affect how they interacted. But it was such a small scale study that we didn't really use the questionnaire to the extent that we may in future if we have larger participant numbers. So once we'd recorded the students doing the experiment, it was about an hour long, we did a titration. Once we'd recorded what they said while they were doing it, the data was transcribed and then analysed using 3 methods. So it started off with a thematic analysis, just coding and categorising the interactions into main themes to see what was going on during the session. We then went into some of the dialogue in more detail and used conversation analysis, so looking at different aspects of interactions, different types of interactions that were going on. And we used something called ESRU coding to look at, again, student and demonstrator interactions, to look at how the teaching and learning was going on. And the references for those 3 analyses are given at the bottom there. So the thematic analysis, we found 5 key conversational types that were going on, 5 key dialogue types that were going on during the session. So there were theory conversations, development conversations, procedural conversations, where is inquiries, and off-topic conversations. So the bottom 2 were probably, we felt, were less likely to lead to sort of more in-depth understanding of what the students were doing. The off-topic conversations obviously were off-topic. The where is inquiries are necessary. They need to be able to ask those questions to people in the lab. So we did look at those to see whether they were asking each other or the demonstrator or so on. But the top three, the theory, the development, the procedural conversations, were where we felt that the learning was going on. So the theory conversations were very much about the background chemistry. So nothing to do with what was happening in the lab, but the background theory and chemistry, redox half equations, that kind of thing. There were development conversations, and they were interactions where a student and demonstrator were having an interaction that was allowing the student to try and understand the context of what they were doing. I'll go through these in the next few slides. And procedural conversations very much about how you do stuff in the lab, not just where it is, but how you do stuff. So the idea of rather manipulative skills and scientific inquiry skills. So they were the 5 key themes. So as I said, theory conversation, they were interactions relating to underlying chemical concepts. There were no examples of students having discussions about the background theory. But there were quite a few student demonstrator examples. I'll show a chart at the end that shows you how many of these conversations took place. But the kind of example of a theory conversation is, do you know what the other half equation is for this? Is it oxidation or reduction? That kind of thing. Development conversations happened again only with the student and the demonstrator. There were no student-student examples, and the students were talking to each other, but not in this context at all. So a development conversation, we defined it as interactions which take the theories behind the experiment and the answers to the pre-lab questions and develop them further, creating direct application to the experiment being completed, so putting it in context. So a demonstrator could ask, what's the key part in this experiment? Why do we want to know? Why would we need to look up expected values? And the student A would say, because we're trying to see how much error we encounter, and so on. It's getting it in context. Again, no student-student conversations there, which was interesting. Procedural conversations, inquiries made about how to complete an action, and those directly about completing that experiment. Not just where is, but questions about how do we do it. So student A might ask, I'm sorry, for weighing this, the vitamin C tablet, do we use a beaker? The demonstrator, well, there's a weighing boat in the top drawer, looks a bit like this, use that, that's a more appropriate way to weigh this, it's a better method. There's also student examples of procedural conversations, quite a lot. Things like, can we use normal water for this as well? Well, it says deionized. I guess the implication is no. So that's between 2 students, student E and student C. So there were examples of both. Where is inquiries? Exactly as it sounds, where do I find this? Student demonstrator examples and student examples there. So evidence of both, they ask both people. And off-topic conversations, I was really surprised to capture any of these actually, because they knew they were being mic'd, and it was just them, it wasn't capturing other students. So one of my favourite ones, we caught more than one, but one of my favourite ones was student E saying, oh, something smells bad. Was that you? Student C, no. They knew they were mic'd, but hey. So obviously it doesn't contribute towards what they're doing. But off-topic conversations, we thought that was an important one to include, A, because it was funny, but B, because that means the students have a relationship. Any off-topic conversation shows there's some conversation, there's some interaction going on, community building going on beyond just the learning. I have heard student demonstrator off-topic conversations. It quite often depends on the confidence of the demonstrator and also time constraints. But in this case, in this study, we only saw student examples. So we counted up all the different types of interactions and we got some rather interesting results. So the main pie chart shows student-student interactions in purple, orange and blue. So you'll notice that there's lots and lots of student-student procedural questions. They're using each other as demonstrators. So we call this a pseudo-demonstrator interaction, where one student is acting as a demonstrator for another. And that's not something we harness. I mean, I kind of knew it went on, but actually, if you think about it, that's something we could really use. We could frame that within our experiments to make sure they're actually working with each other. Yes, there's some where is and off-topic conversations. The grey wedge in my pie chart there is the student-demonstrator interactions. So they're much fewer than the student-student interactions. When I've got students working individually, they're not doing it in silence, they're talking to each other. And the student-demonstrator interactions, no off-topic, fewer procedural than I would have expected, fewer where is than I would have expected. They use each other for those. But the theory and development conversations, they are solely student-demonstrator interactions. So I thought that analysis was quite interesting. So in summary then, for thematic analysis, we found that higher frequency of interactions regarding experimental procedures occurred between students, far higher than I thought they would. Conversations regarding underlying chemistry theory occurred only with the demonstrator. Now, this was a small-scale study, so it may be that there'd have been more had we had more students, but both the student-student and student-demonstrator interactions promoted learning. Those procedural conversations, not just where is, but how is this done, I think they promote learning that's really useful in a laboratory, and so, yeah, maybe we should harness it a bit more. Those that encourage psychomotor learning tend to be procedural stuff. They tend to be student-student interactions, so they're really important. But the ones that promoted cognitive learning in this study only appeared in student-demonstrator interactions. It would be nice if we could get those in student-student interactions as well, so there's more of it. So moving on then, with second type of analysis, we looked at the exact type of interactions, focusing mainly on transcripts of discussion about pre-lab work where we had a sort of longer conversation. And Megan looked at types of conversation features to try and see how many were being used. So the 4 categories, and I'll talk you through them, were turn-taking organisation conversations, asymmetries in knowledge, repair organisations, and use of polarised questions. So going through those in turn. Turn-taking organisations were where you have conversations where you've got literally ask, respond, ask, respond. We saw quite a lot of that between the student and the demonstrator. The demonstrator was asking lots of questions, the student was replying, and we were getting longer exchanges where actually we saw development of theory and the context. So development conversations were about context. There were some turn-taking conversations with between the students, but they were shorter, and they usually tend to be, just 3 turns. Did you pipette both? Yeah, okay. They weren't sort of expanding knowledge as much. Asymmetries in knowledge is where we got evidence of disconnection between the student agenda and the demonstrator agenda. So the demonstrator was sort of seeking the expected answer. They had set questions that they wanted to ask. The student was seeking the right answer, because that's what worried students do in a teaching lab. And it wasn't clear that knowledge or understanding was secure. There was an interaction that took place, and it wasn't clear that anything productive had happened during that. But it could be that the demonstrator thought it did. So, for example, demonstrator, is there anything else you could compare it with? Student B, anything else? So demonstrator, so one of the key things about this experiment, especially the second part, is we want to see how the value we get compares with the expected values that you find online, yeah? Student B, yeah? The demonstrators, they've communicated this information, but it's not clear that the students learned anything. So I think the demonstrator may have walked away thinking that the student's secure in that knowledge, whereas the student might be going, yeah, all right, if you say so. So I think it's quite key to identify those. We also saw repair organisations, so sort of correctional type questioning, where the demonstrator gives clear questions or guides questions, follows up with feedback and answers, and that feeds into the cycle, the third analysis that I'm going to talk about in a couple of slides. We saw theory development happening in these kind of interactions, but we didn't really see it in student-student interactions. Student-student interactions, again, were shorter, more quickly resolved. So students speak to other students for quick, short answer questions, but they discuss with demonstrators. And I'd love to be able to promote that level of discussion with students. Will be good to see whether they do that by the time they get to third year, but this was a first year group. Use of polarised questions is always something to look for when you're analysing questioning for knowledge development, because closed questions leave little room for exploring understanding. They actually probably happen too much between the demonstrator and the student, and it made me think that maybe I need to train my demonstrators a bit better to make sure that they're not using those. So there were lots of questions, things like, does that make sense? Or did you understand that? Or is that all okay? And I guess the only right answer to that is yes, but it doesn't mean I thoroughly understand everything. It just means the conversation has come to an end. So that made me identify a training need. So in summary, the demonstrator facilitated learning quite well via conversations with the students. It was an important part of the lab, I think. Often opportunities were missed, though, for more in-depth exploration of students' understanding. And that could have been that the demonstrator was rushing around trying to get to everybody to ask the key questions. But it could be that I need to train them a bit better to make sure that they're actually allowing the students to process their understanding by asking and answering questions as they go through and not shutting them off with a lecture style, here's your answer. So the third and final type of analysis that we used was using this ESRU model. In short, it means the teacher elicits information from the student by posing a question, student responds, Teacher recognises the response and then uses the information obtained to further the student learning. So it's sort of a question, answer, feedback loop. I guess the idea and the theory behind it is that the more cycles you have, the more a student can progress along their understanding pathway to make progress through their learning. So what we looked at was, again, the same kind of demonstrator-student interactions, and we looked at classifying each of the interactions as one of E, S, R, or U, and looked to see how many cycles were completed. And the assumption was the more cycles, the greatest chance for students to make meaning and understanding through the interaction. We also considered incomplete cycles and thought about whether they were missed opportunities or not. So from 4 conversations with demonstrator and 4 different students, only 2 of those conversations had 1 complete cycle. And then there was lecture-style explanations and the discussion was stopped. The other 2 had 3 complete cycles, but only 1 student was successful, as in got to the point that the demonstrator wanted them to get to by appropriate question, answer, cycle, feedback processes. The other student got through 3 complete cycles and then the demonstrator just sort of gave up and gave them the answer. So it's an interesting model, and it gave us some more insight into the data that we had. And it also made me think, could we use this model as a training aid for demonstrators to make sure that they have 1 or 2 complete cycles of these conversations with each student that they're working with? Might help increase understanding in the laboratory. So conclusions. Student-student interactions were way more important than we had actually thought, despite the fact we listened to them in the lab all the time. They use each other as pseudo-demonstrators, and it struck me that we should probably try and harness that. Demonstrator-student interactions are key, as we would hope, to allowing students to access high-level thinking and understanding, and again, we can harness that. And my demonstrator training needs to include more training in effective questioning and student discussion techniques, maybe using some of these theoretical frameworks that we've talked about. And we're hoping to go on and do more studies in this area. I'd be really keen to get students who are working on the same experiment as a pair mic'd up to see whether the types of interactions change. Does that encourage them to talk more? Sometimes I wonder. I'd love to do more demonstrator-student studies. This was a very small-scale study, and more student-student studies. I was fully expecting really confident students to volunteer for this, but actually we had a really interesting range. We had a gender balance, even just from 4 students. So I'd love to do more and see whether we can get any generalities there. So my thanks go to Megan, who conducted all the research. She's my 4th year student, has just graduated just last week, 2 weeks ago. Thanks to Helen, who co-supervised with me the project students we've had this year. Helen's a whiz at things like ethics and data analysis, so she's a great co-supervisor to have on board. And thank you to my 1st year and postgraduate demonstrator volunteers. I'm happy to take questions at the live session. I'll be there on Friday, or alternatively drop me an email. Thank you.